Hi everybody, this is Mrs. Costello. We are starting unit 4. We are doing a lot of graphing in this unit. So today is kind of like the intro day on graphing. There's going to be a lot of vocab, a lot of just practicing with some stuff that we probably did in Algebra 1, but I know it's been a hot second since we've been in Algebra 1, so we might need a little bit of review. Okay, so speaking of review, we have 2 review problems right here. These are both from our last unit, so I want you to solve this quadratic equation and find the zeros in here. And then number 2, same thing. So why don't you go ahead and pause your video and do those? When you unpause your video, you're going to see my solution. So go ahead and pause your video now. Okay, so here's all my work on number 1 and number 2. On number 1, I did move the 5x and the 60 over to make my own 0. I did try to do x factor up here because you always try to do that just in case it works. And so sorry, it did not work. So we had to use quadratic formula. And all my work is right here for quadratic formula. And then I was able to simplify it down to this, which should be answer choice B. So go ahead and check your work, make sure it looks good. And then the second one, number 2, I had to move over the x or the 8x, sorry, and then factor and find my zeros. So I know sometimes you see these and you're like, I have no idea what to do. Just make your own 0 and you're good to go. So today we're going to be graphing quadratic functions. So we worked with quadratic functions last unit, and it's still in the same form, like it's still in that ax squared plus bx plus c. So this x squared is usually like your tell that you're working with a quadratic function if it has that x squared. Okay. When you graph a quadratic function, it makes a shape that's called a parabola. And you might have heard that from Algebra 1. Okay, it just makes a U shape like this. So this is just the shape of the quadratic function. Okay, sometimes your parabola is upside down also, like that. And we'll talk about like the difference between those two in this video. Every single parabola has a vertex. Now the vertex is like your center of your graph. So like it's usually the very, very bottom or the very, very top of your parabola. So your vertex is like your x and your y. It's kind of like the starting point of your graph as well. Okay. Now with the vertex, it comes something called the axis of symmetry. Okay, the axis of symmetry is just a vertical line that splits your parabola in half. That splits the parabola in half. So like it kind of creates a mirror. So like if you took your parabola and you took your piece of paper that your parabola was on and you folded it in half, like both sides of your parabola should be the same. So like the left side and the right side should be the same. That's what your axis of symmetry does. So like here's my little parabolas. If I drew a line right there, then it would, cut through. Now your axis of symmetry is always x. It's always an equation, x equals, and then you always put in the x part of the vertex. And we're going to work on that too. Oops. Okay. All right. Now, every parabola either has a minimum value or a maximum value. If it has a minimum value, it looks like this. Okay. It's an upward facing parabola, and this vertex is going to be your minimum value. Now, you usually talk about the y values when you're talking about your minimum value. So you would put like minimum value, y equals, and then the y part of the vertex. And that makes sense because your parabola is facing up. So it's going up and up and up forever and ever and ever. Now the maximum is kind of the opposite. Okay. if your parabola is facing downwards, you have this top right here. That is like the maximum y you're ever going to get on your parabola. So it's going to be the y value of the parabola, or sorry, of the vertex. And on this one, like your graph is getting smaller and smaller and smaller forever. So that's why it has a maximum. Okay. Alrighty. Now, most of you guys know how to graph quadratic parent functions. The quadratic parent function is just y equals x squared. Okay. So we do have a table of values. So I am going to go ahead and give you the x's. So use -2, -1, 0, 1, and 2. So what I would like you to do is I would like you to plug in these numbers for x into our parent function to find the y values for that coordinate. Then I would like you to plot those points onto this graph. Okay, so please go ahead and do that. Pause your video, and then you'll see my table and graph completed. So go ahead and pause your video now. Okay. So there's my graph, and there's my points. Just be careful that when you plug in the negative, it looks like this. It looks like y equals -2, and then you square it. Because then you're going to get that U shape. If you don't actually do -2 times -2, you're not going to get that U shape. Now, if you look at our like y coordinates, or even in our v, like if you, the 0, 0, this is our vertex right here, okay? And we're going to kind of I know we're going to kind of fill that out in a little bit, but I kind of want to go over what exactly is going on when you go from point to point. So if I started here at 0, how I would get to the next point is I would add 1, and hopefully you see that. Then if I got to the next point, I would add 1 to 4, you're adding 3. Okay. If I kept going, my next point would be +5. Okay. Now this is a common rule that you use with your parabolas. You go up 1 over 1, up 3 over 1, up 5 over 1. So I know in my class, like I always say, like use your 1, 3, 5 rule. That's what I'm talking about right here. Okay. So we already went over what the equation is. The equation is y equals x squared. That's your parent function. Okay. Your vertex is right here, that center, or that middle. In this one, the vertex is 0, 0. Okay. Your axis of symmetry, remember that your axis of symmetry is going to be the x part of your vertex. So x equals, and then 0 is the x part of my vertex, which means like if I were to draw it in, it would split my graph down the middle right there at the vertex. That's all it's saying. We have to look at if it has a minimum or a maximum. Because my parabola is facing up, it has a minimum value, and the minimum value is going to be the y part of my vertex. So my minimum value is going to be y equals 0, because that's the y part. Okay, so my domain, my x's are getting both smaller and bigger at the same time. So my domain is going to be all real numbers. This is fine with me, but I think on your final you might see it in interval notation. Remember that all real numbers in interval notation is -infinity to +infinity. Now my range. This is an upward facing parabola, so the y's are getting bigger. Okay, from your vertex, right? Your vertex is always going to be part of the range. So it looks like I start at 0, so I'm going to include 0 with a bracket because it's part of the line. So 0 to +infinity because they're getting bigger. Or if you're using that inequality notation, you would say y is greater than or equal to 0. So those are my basics. For the most part, those are my basics. All right. So properties of my graph. This is the last box, and then we're going to do some graphing. So if A is greater than 0, so here's A. If it's greater than 0, that means it's a positive number, which means my parabola is going to be facing upwards. Now, if A is less than 0, that means oops, I messed this up. Sorry, this is the less than, this one's the greater than. My bad. So this one is negative. This one is positive. So that one would be the one where my parabola is facing up. My bad. This one, if my parabola is negative, that means that I reflect it, so it's facing downwards. Okay, that's the only thing with that. If you're leading if there's a negative in the front, it's definitely going to be flipped. Then if absolute value of A is less than 1, so that means that we're talking about like a fraction or decimal less than 1. Okay, what that means is it means that my my graph is being compressed by, so it's going to be like kind of getting smashed. So it's going to be like a really wide parabola because it's going to be it's going to be like flattened a little bit. Then if A is bigger than 1, that means it's most likely a whole number or like a fraction that is bigger than 1. And that means it's going to get kind of stretched. So it might be like really, really, really skinny, not getting flattened. It's just going to be stretched up. Okay. And if you have different numbers in here with 1, you need to do your 1, 3, 5 rule and then multiply like A by it. And you're going to see me doing that too if you want to do that. We kind of already went over axis of symmetry. So, well, to find the axis of symmetry, if it's in standard form like this, which all of our equations are going to be today, you just have to do negative b over 2a. And that's how you find the x part of the vertex, which we talked about, is like your axis of symmetry. So x part of vertex is your negative b over 2a. Then if you want to find the y-intercept, you would plug in 0 where all the x's are. Plug in 0, which really just means like it's going to be c if it's in standard form. So plug in 0 for x. And then I'm going to put c in standard form because some of these are already in standard form. All right, so let's graph. Okay. All right, if you would like to plug in x's and y's into number 1 to graph it, I mean, you can. I don't really like to, but if you really, really want to, you could. Okay. I'm going to do my vertex by finding like the x part, which is that negative b over 2a. So if this is a, b, and c, I'm going to do that. So b is 4, so negative 4 over 2a. A is negative 1. So negative 4 over 2 times negative 1 is negative 2. So negative 4 over negative 2 is positive 2. Now that's the x part. To get the y part, I need to plug in 2 where all the x's are on my equation. So y equals negative 2 squared plus 4 times 2 minus 3. Notice how the negative stayed outside right here because it's kind of like a coefficient. Okay. So y equals, this is going to be negative 4 plus 8 minus 3, which is, let's see, this is 4 minus 3, which is 1. So my vertex is at 2, 1. Okay. So 2, 1, that's where my vertex is. Okay. Now let's look at the a value to figure out what exactly I need to do with my 1, 3, 5 rule. Maybe we can use this table for that. 1, 3, 5. Okay. So my a value is technically that negative. So I need to times each thing by negative 1 to see where exactly I'm going next on my graph. So I'm going to do down 1 over 1, down 3 over 1, and down 5 over 1. So down 1 over 1, down 1 over 1. Remember to make that U shape, so you have to do it on both sides. Down 3, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3, 4. You can go off the graph for 5 if you want, but most of the time you just do 1 and 3. And there's my parabola. Okay. So remember the axis of symmetry is the x part of your vertex. So x equals 2 is the x part. Then my y-intercept, you could plug in 0 into your equation, or you can look at your graph and you can go, oh wait, here's my x-intercept, or sorry, my y-intercept, which is at 0, -3. Or you could even look at it and go, oh yeah, it's going to be C, because if I plug in everything, it's going to go away. So more than one way to find some of these things sometimes. Okay. Why don't you guys go ahead and try to do number 2. You know how to find the vertex. You know how to find the axis of symmetry and the y-intercept because I just did it. And then I know there's some new stuff, but I think you could probably figure it out. So go ahead, pause your video now and do number 2. So here's my work so far on number 2. I got 3, -4 for my vertex, and hopefully you got that too. I plotted it on my graph. My A value was just 1, so I was able to follow that 1, 3, 5 rule the whole time, which is great. And so then my axis of symmetry, remember, is the x part of the vertex. The y-intercept, I found it on my graph, but also C is also the y-intercept. So that's where we're at. Now here's the new parts, kind of new parts. This graph, does it have a minimum or a maximum? It has a minimum because it's facing up, and then the minimum is going to be y equals, and then the y part of my vertex, which is -4. Your domain is always, always, always going to be all real numbers, or if you're using that interval notation, -infinity to infinity. The range, well, the parabola is facing up, so that means that the y's are getting bigger. So I'm going to start with the y part of my vertex, which is -4, go all the way to infinity. Or if you're using that inequality notation, y is greater than or equal to -4. Okay. All right, we have one more graph that I do want to go over together. So this is now B, there is no B, because usually B has like just the single x, there's no B. So we're going to pretend that B is 0 since it's not there. And then C is right there. That I always like to go over this one because everybody kind of gets thrown off with that B equals 0 part. So you don't have to do the -b over 2a since B is 0. That also means like I'm going to have 0 on top over 2 times -2, and we know that's just going to be 0 for the x part of your vertex. For the y part, we still plug in, even though this says g of x, you're just going to use y equals -2 times 0 squared plus 2. And we know this guy's going to go away because anything times 0 is 0. So the y part of my vertex is 2. So 0, 2 is going to be my vertex, okay, which is also my y-intercept. That's nice, okay. Now this time my A value is -2. So I'm going to write my 1, 3, 5 on the side, and I'm going to do times -2, times -2, right, times -2. So 1 times -2 is -2. 3 times -2 is -6, and 5 times -2 is -10. You might not make it to all of those, but that's okay. So down 2 over 1, down 2 over 1, we can definitely go to 6. 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. Okay, see how that kind of stretched it and it made it like kind of skinny? That's what it means with that, like, that stretch and compress. So this one's kind of stretched out a little bit. Alrighty. This one is facing down, so I do have a maximum. My maximum is going to be at y equals 2. Again, domain, easy point on your test. It's always all real numbers or -infinity to infinity, whichever way you're doing it. The range, this time my y's are getting smaller. So if I'm using that interval notation, if they're getting smaller, they're going towards -infinity forever. Okay. Then the biggest y is going to be the y part of my vertex, which is 2, and I'm still going to include it. or you can use inequality notation, so y is less than or equal to 2. And then the only other thing I need to put in is my axis of symmetry, which is the x part of my vertex. So x equals 0 is going to be the axis of symmetry. Okay. 4 and 5, you need to find the minimum or maximum value. So first you need to ask yourself if your parabola is upward or downward, okay? And then we're going to find the y part of the vertex on these. Okay. So number 4, there is a negative in the front. So I know my parabola is facing downwards, so I am going to have a maximum on this one. Now to find the y part, I do have to do my negative b over 2a to find the x part. So x equals negative 12 over 2 times negative 3, because negative 3 is a. And then I have negative 12 over 2 times negative 3 is negative 6, so positive 2. Then I'm going to plug in 2 where everything is to find the y value or the maximum. So negative 3 times 2 squared plus 12 times 2 minus 6. Okay. Now, if you put this whole thing in your calculator exactly like how it is, it's going to spit out the right answer for you. So you just need to make sure you use the right parentheses. Okay, so if you do that, you're going to get 6. Okay. So your vertex is 2, 6, which means you have a maximum at 6. So the max is at y equals 6. Number 5, same thing. There is no negative in the front, so I know my parabola is facing upwards. So I'm going to find a minimum this time. This is A, B, and C. So for the x part, I'm going to do negative b, so negative 21 over 2 times a, and a is 7. So negative 21 over 14, we do have to reduce that. So that's going to get me negative 3 over 2. Yay. Now, I know we don't love using our fractions, and that's why I said, like, if you plug this in, if I do 7 parentheses, negative 3 over 2 squared plus 21 times negative 3 over 2 plus 8, and if you plug it in your calculator like that, it's still going to give you the right answer. So don't worry about that. Like, just plug it in with all the parentheses, see what you get, and then that's going to be your y equals. So when I plugged it in my calculator, I got 95 over 4, which I know kind of stinks, like, doing that by hand. So if you did it as a decimal, that's fine. Like, if you changed this to 1.5, that's also okay, and then added it up, then you would have gotten, I don't know what that is. Let me do it in my calculator. 23.75. Either one is fine. So then you would say minimum at y equals 95 over 4, or 23.75. All right. So I know that was kind of a long video. That was a lot to go over in day 1. If you have any questions, please ask me or ask your teacher tomorrow during class. Otherwise, have a good rest of your day.